Okay, here's a quick video on simplifying radicals, kind of the way that we did in class. So what we're going to do here is we're going to break down this square root, what's inside the square root, into its like smallest basic pieces, and then we're going to kind of attack that one by one in order to find the simplest way to write this radical. So whenever I say break things down, this is where in class we would take, say, the number 90 and break it down into its prime factorization. Now, whenever I see a number like 90, that's an even number. I always go with 2 first. 90 is 2 times 45. And then you might go with 3 or 5. Like this one is very obviously divisible by 5. And 45 is 5 times 9. Of course, you get a calculator to help you out with this. And then 9 is 3 times 3. So it's prime factorization is breaking these numbers down into numbers that are not divisible by anything else. So 90 can be rewritten as 2 times 3 times 3 times 5. And then I'm going to take all these variables and I'm going to rewrite them as their repeated multiplication. So x cubed is x times x times x. Y to the fourth is y times y times y times y. And z to the fifth is z times z times z times z times z. So this is what I mean by we're going to take these numbers and we're going to break them down in the variables and break them down into its smallest possible pieces. And then we are going to look for pairs in order to, and that we're going to find the square root of. So for example, 3 times 3, that is 9, right? Whenever I take the square root of 9, it turns into a 3. So whenever I see a pair of 3's inside the radical, it's like those can be brought out as a single 3. And anything else that's a pair, I can do the exact same thing too. So I have a pair of x's. That pair of x's can be brought out as a single x. I have a pair of y's. And then another pair of y's. Each one of those pairs gets brought out as a separate y. And then finally we get to the z's. I have 2 pairs of z's and 1 left over. So each of those pairs is written as a single z on the outside. And then we're going to account for everything that's on the inside of the radical still. I have a 2, I have a 5, I have an x, and I have a z. So those are all the things that are left over on the inside. And then we're pretty much to the point where we have one more step, and this is going to be simplified. So on the outside, what I'm going to do is I'm going to see, is there anything that I can like rewrite with, say, exponents, or I can multiply? Nothing I can really multiply with 3. And then I've got x. Well, then I've got this y squared, this y times y, which I can write as y squared, or z times z, which I can write as z squared. So I'm going to kind of clean up everything on the outside and use some exponents to represent y times y to become y squared, z times z to become z squared. And then anything on the inside that can be multiplied, I'm going to do the exact same thing. So for example, 2 times 5 I can rewrite as 10. And then I've got x times z, and nothing can really happen with those. And that's it. That's my final answer. I can look at the inside, just double check. You might want to ask yourself, hey, is there any perfect square like 4 or 9 or 16 that can go evenly into 10? And the answer is no. Nothing except for 2 and 5 can multiply into 10, so that should be good. You can kind of double check your answer, but all in all, that is pretty much the process. Well, I hope this quick video was helpful. I'll see you in class.